Okay, good morning. We are going to start, and today we are going to change gears from conditional probability, independence, finding the probabilities, counting. We have done all that in the past 3 weeks, and today we are going to start with the random variables. Today we will talk about discrete random variables, and in the next lecture as well, we will talk about some discrete random variables. Next week, we will get an opportunity to talk about what we call continuous random variable. So what is a random variable? What is a random variable? Okay. Random variable. So we have been in the course talking about a random experiment. When you perform a random experiment, you have a sample space, which has many outcomes, 1, 2, 3, 4, and there can be many other outcomes. So we understand that when you perform the experiment once, exactly one of the outcomes will occur. And then we can define events on this sample space by taking unions of some of the sample points. So an event will contain 0 or more sample points. Okay? And it is totally up to us how we define the events. Totally up to us. Okay. So what is a random variable? The random variable is closely tied to this sample space and the outcomes. And it is basically a variable which takes numerical numbers, in fact, real numbers. So there is real line here. Yeah, आपके पास real line है. This is real line. That means line on which you have real numbers. If you take each of the possible outcomes, and map that, किसी तरह से map करेंगे. Okay. So for example, you can say कि there is this outcome here, ये वाली, और इसको मैं map कर देता हूँ इस जगह के ऊपर. Okay. So that means whenever this outcome occurs, then I can read some number here. Maybe this is 48. हम इसको read कर सकते हैं. ये 48 है यहाँ पे. ठीक है? Similarly, if this outcome occurs, maybe I will say कि this number will occur, which is 31. So what we are saying here is that whenever you perform the experiment, you will get exactly one outcome. We don't know which outcome would that be. हर एक की probability है, and mostly equally likely होती है, not necessarily though. And what we can do is we can map these outcomes. When red outcome occurs, then I will say that there is a number 48. When green outcome occurs, then we will say that there is a number 31. That number, that variable which encompasses these numbers, we call that a random variable. Similarly, this blue guy, I can map this here, and then I can get this brown guy also mapped to the same number. ऐसा भी हो सकता है कि दो आउटकम्स को मैं एक ही नंबर पे मैप कर दूं, and maybe this number is 39. This number is 39. So whenever blue outcome occurs or the brown outcome occurs, my random variable जो मैंने ये define किया है, this mapping से define किया है, this mapping is defining a random variable. This mapping is defining a random variable. Now you can see कि same sample space, same set of outcomes, मैं mapping को अगर change कर दूं तो मेरे पास एक और random variable आ जाएगा. Mapping को और change कर दूं तो yet another random variable. So the random variable, the values that the random variable will take will really depend upon what the mapping is. And I can define this mapping. ये हमारे ऊपर है कि हम उस mapping को कैसे define करते हैं. So I will give you an example. The example is our old friend coin. Toss a coin, fair coin. We know that probability of getting a head or a tail is 1/2. It's a fair coin. I define a random variable. We know, okay, the outcomes are head or tail, and I define a random variable such that इसको नाम भी को दे देते हैं define x to be equal to taking some values and totally arbitrary value, totally up to us how we define those values, 37 and 48. 37 and 48. ये दो वैल्यूज इसको दे देते हैं, if head and if tail. What means कि अगर tail आ गई तो ये मैप करके ये 48 पे चला जाएगा, और अगर head आ गया तो ये 37 पे. So now if I ask you the question, what is the probability that a head occurs? Everyone knows the answer. It's 1/2. What is the probability that a tail occurs? Again, 1/2. If I ask you the question, what is the probability that x takes the value 37? What is this probability? Answers in the chat window. What is this probability? This probability is 1/2. Why? Because x takes the value 37 when head occurs. So ये मैपिंग जो आपने की हुई है, एक हेड को मैप कर दिया नंबर 37 के ऊपर, ठीक है. So this guy here, x taking a value of 37, this is an event. Remember, we are familiar with finding the probabilities of events. हम तो probability event की find करते हैं. So x taking a value 37, this is an event. This is an event which has just one outcome. इस event के अंदर एक ही outcome है कि आपके पास head आ गया, ठीक है. So the probability that x takes a value 37 is 1/2. What is the probability x takes a value 94? Answers in the chat window. Zero. It doesn't take the value 94. Okay. So now these probabilities, if all possible values that x can take, if all possible values that the random variable can take, if I list those values and the corresponding probabilities, okay. So list of all possible values x can take and corresponding probabilities. This tells me everything about the random variable. This tells me everything about the random variable. Okay. And this information, by the way, this is called the probability mass function. इसको probability mass function भी कहते हैं, PMF. There is a way to draw this as well, and the way that we will draw this is, ये आपके पास real line है जिसके ऊपर the random variable can take two values, 37 and 48, with non-zero probabilities. So 37 and 48, and you have a probability of 1/2 and the probability of 1/2. This is your PMF. This is your PMF diagram. आपके पास आपकी PMF diagram. And the way that we describe this PMF notation जो इसकी है, उसको हम लिखते हैं small p से सबस्क्रिप्ट में रैंडम वेरिएबल का सिंबल लिख देते हैं और ब्रैकेट में स्मॉल x लिख देते हैं. एंड स्मॉल x रियली इंडिकेट्स कि ये कौन कौन सी वैल्यूज ले सकता है. स्मॉल x is a variable, but it is not a random variable. Capital X is a random variable, and the capital X will take one of the values small x. Okay, so for this example I can say that px of 37 is equal to 1/2. Px of 48 is also equal to 1/2. Okay? And this is a set of all possible values that x can take, uski list hai, and the corresponding probabilities. So this is PMF. Okay. Convince yourself, or probably it is obvious for you to see, that x will take one of the values, जो भी possible values ले सकता है. हमें पता है कि sample space में से कोई ना कोई outcome तो occur करेगी, तो जो भी values x ले सकता है, अगर मैंने वो सब की सब list कर दी है, exhaustive list है उनकी, so the sum of all of these probabilities, summation of px of x summed over all x should be equal to, answers in the chat window, should be equal to 1. Always. यानी यूं देख लें कि जब हमने कहा था प्रोबेबिलिटी ऑफ द सैंपल स्पेस इज 1 इज गारंटीड टू अकर, एक आउटकम उसमें से आएगी और लाजमी आएगी, ठीक है। बिल्कुल उसी तरह अगर मैंने रैंडम वेरिएबल की सारी वैल्यूज, पॉसिबल वैल्यूज लिस्ट कर दी हैं, तो इसका मतलब है रैंडम वेरिएबल उनमें से कोई ना कोई वैल्यू लेगा। सो चांसेस दैट कोई एक वैल्यू लेगा, ये दूसरी या तीसरी, कोई ना कोई एक तो वैल्यू लेगा। सो those values, sum of all of those probabilities will be equal to 1, because one of the values will, it is guaranteed that the random variable will take one of those values. That is how we have defined the PMF. That is how we have defined the PMF. Okay. So one more example here. Example: toss a coin repeatedly at most n times, at most n times, at most n times, ठीक है। Important to note this is at most n times or until a head appears, until a head appears. So आपने coin toss करना शुरू किया, n was 30, ठीक है। So if you saw the head on the first toss, you will just stop there. If you saw the tail and then saw the head on the second toss, then you will stop there. अगर आपकी 30 tails आ गई हैं, then you will stop there. अगर कुछ head मिला ही नहीं है, 30 tails आ गई हैं, you will stop there. So let's say on each toss, probability of head showing up is P. So that means on each toss probability of tail ये क्या हो जाएगी 1 minus P. सिर्फ head आ सकता है, ये tail आ सकता है. So let me define a random variable here, and the random variable that I'm going to define is x. मैं कुछ भी use कर सकता हूँ, x, y, z. It's really up to us. Okay. X is the number of tosses. X is a random variable. I am interested in the PMF of X. PMF का क्या मतलब है? PMF में आपको बताया था, list all the possible values X can take and the corresponding probabilities. What are the possible values X can take? Answers in the chat window. Values X can take. What are the possible values X can take? Bilal says 1, 2, 3, all the way. Abu Bakr says head or tail. Remember, random variable is a number. It is not head or tail. Abu Bakr, so head और tail जो है वो outcomes हैं, उन outcomes को आपने numbers के ऊपर मैप कर दिया है. So वो जो numbers हैं, random variable वो values लेता है. So the random variable can take, X can take value 1. When does X take a value 1? X takes a value 1 अगर पहले toss के ऊपर head आता. X can take value 2. When does X take value 2? X takes value 2 when पहले toss पे tail आया और दूसरे toss पे head आ गया. X can also take value 3. When does X takes value 3? Tail and then head and then you stop. ठीक है. X can take value 3, 4, 5, 6, can take value n. So these are the possible values that X can take. Is this the PMF? Yes or no? Answer in the chat window. Is this the PMF? This is not the complete PMF. ये आधी चीज उसने बताई है. PMF में हम ये सारी values भी बताते हैं और हम बताते भी हैं कि X takes the value 1 with what probability. I need to tell what are the corresponding probabilities. So I need to tell what is the probability X takes the value 1. What is the probability X takes the value 1? Answers in the chat window. What is the probability X takes the value 1? The probability of head on a given toss, on each toss, the probability of head is P, probability of tail is 1 minus P. Okay. So what is the probability X takes a value 1? When does X take a value 1? कब ऐसा होता है कि X takes a value 1? कब ऐसा होगा कि पहला टॉस किया और आप स्टॉप कर देंगे वहां पे? When will that happen? That will happen if the head appears on the first toss, if the head appears on the first toss. So answers in the chat window. What is the probability? What is the probability x takes a value 1, जिसको ऐसे भी लिखते हैं px of 1. What is this probability? Answers in the chat window. कोई एक तो आंसर कर दे भाई. So P, it's P. It's not 1/2. Well, P 1/2 हो सकता था, but हमने तो यहाँ पे जरा जनरलाइज कर दिया. जरूरी नहीं है कि ये फेयर कॉइन हो. हमने कहा है probability of head is P and probability of tail is 1 minus P. So the probability x takes a value 1 is you see a head on the first toss. See head on first toss. What is the px2? Probability x takes the value 2. What is this probability? Answers in the chat window. Answers in the chat window. कब ऐसा हो सकता है कि x will take the value 2? X will take the value 2. पहले टॉस पे क्या आना चाहिए? पहले टॉस पे टेल आना चाहिए. अगर हेड आ गया तो मैं तो वहीं पे स्टॉप कर दूंगा, तो x1 हो जाएगा. Because x is the number of tosses. X is the number of tosses. So I don't want to stop at the first toss. If I don't want to stop at the first toss, then the first toss must not be a head. It must be a tail. The probability that it is a tail is 1 minus P, and then the second guy is a head, which is with probability P. So px3, what is this probability? Answers in the chat window. Answers in the chat window. X takes a value 3. X takes a value 3 when the first two tosses are tails and the third toss is a head. px4 is 1 minus P power 3 into P. pxn minus 1 would be equal to, अगर ऐसे ही चलते जाएं, ये पैटर्न हमें क्या बता रहा है? What would be the probability that x takes the value n minus 1? X takes the value n minus 1 is कि पहले n minus 2 tosses के अंदर tail आ जाए और n minus 1th toss is a head. ये n minus 2 की tail आ गई है and the nth toss is a head. Okay. So this is n minus 2 tails followed by a head. N minus 2 tails followed by a head. So n minus 2 tails followed by a head. What is the probability? देखें, यहां से हमने क्या शुरू किया था कि x कौन कौन सी वैल्यूज ले सकता है? x वैल्यूज ले सकता है 1, 2, 3, 4 all the way up to n. तो हमने कहा ये अभी PMF नहीं. So in order to find the PMF, I need to find the corresponding probabilities. What is the probability x takes the value 1? We found that. What is the probability x takes the value 2? We found that. Value 3, found that. 4, 5, etc. n minus 1. एक ही रह गई अब. What is the probability x takes the value n? What is the probability x takes the value n? Answers in the chat window. Answers in the chat window. What is the probability x takes the value n? Abu Bakr, this probability cannot be 1. If this probability is 1, that means you are saying कि आपको n ही toss करने पड़ेंगे. ओ भाई ये नहीं हो सकता. हो सकता है आप पहले ही रुक जाएं. तो the probability of x taking the value n cannot be 1.
सर ये n-1 तक तो टेल्स आएंगे ना, तो लास्ट वाला रह गया सिर्फ एक हमारे पास सीन, तो उसके अंदर तो हेड ही आएगा हमेशा. जैसे अगर कलेक्टिवली एग्जॉस्टिव करना है इसको कि सबका सम करें तो एट द एंड 1 आना चाहिए.
नहीं, अगर लास्ट वाले के ऊपर भी टेल आ जाए तो फिर क्या होगा?
सही है.
आप फिर भी स्टॉप कर जाएंगे. आप फिर भी स्टॉप कर देंगे बिकॉज यू हैव एट मोस्ट n टाइम्स. n से ज्यादा नहीं कर सकते भाई, n से ज्यादा नहीं कर सकते. Okay, so probability that x takes a value n is that first n minus 1 tosses, you see a tail and then you see a head, or first n minus 1 tosses you see a tail and then you see another tail, which turns out to be equal to 1 minus p power n minus 1. 1 minus p power n minus 1. So what is this probability? This says first n minus 1 are tails, and that makes complete sense. Why? this makes complete sense is हम कह रहे हैं कि first n-1 are tails, इसका मतलब है आप पहले n-1 पे नहीं रुके हैं, आप नहीं रुके हैं, कोई हेड नहीं आया पहले n-1 में, आप नहीं रुके हैं, n-1 टॉसेस आपने किए, सबकी सब टेल्स आई, अब आपने आखिरी टॉस करना है. I don't care what happens on the last toss. हेड आता है या टेल आता है, जो मर्जी आए, मैंने n के बाद रुक जाए, क्योंकि n से ज्यादा तो मैं टॉसेस कर ही नहीं सकता. So last toss here is immaterial. I don't care what will happen, whether it would be a head or a tail on the last toss. Okay? So verify at home that summation I is equal to 1 to n pxi is equal to 1. ये आपके पास बड़ी एक नाइस ज्योमेट्रिक सीरीज बन जाएगी. ज्योमेट्रिक सीरीज का आप सम करें और ज्योमेट्रिक सीरीज का सम करके आपको ये पता चल जाएगा ये this will be 1. So in summary हमने क्या किया, हमने एक सैंपल स्पेस ली, उसकी आउटकम्स को नंबर्स पे मैप कर दिया, एंड द रैंडम वेरिएबल जो हमने डिफाइन किया वो नंबर्स ले रहा है. दिस मैपिंग विल टेल यू कि what that random variable is, what values the random variable can take, and the corresponding probabilities. You can list all the numbers, all the values that the random variable can take, and the corresponding probabilities. That gives you the probability mass function PMF of the random variable x, PMF of the random variable x, and the sum of the PMF over all possible values of x, over all possible values that x can take, the sum of the PMF is 1. Sum of the PMF is 1. So that's the summary of what we have done so far. Okay. So some examples of the random variables. Number of rainy days in a week. हफ्ते में 7 दिन होते हैं, कितने दिन ऐसे होंगे कि रेन होती है? So that's a random variable. That is a random variable. What values the random variable can take? Number of rainy days in a week. Number of rainy days in a week, it's a random variable. What values that random variable can take? Answers in the chat window. 1 to 7. 1 to 7. एक दिन भी हो सकता है, 2 भी हो सकते हैं, 5, 6, 7 भी हो सकते हैं. ठीक है? So number of goals scored by a team in a season. Number of goals scored by a team in a season. That is also a random variable. वो कौन-कौन सी वैल्यूज ले सकता है? कौन-कौन सी वैल्यूज ले सकता है? Number of goals scored by a team in a season. एक सीजन में कितने गोल करेगी टीम? 1 to infinity. 1 to infinity. 0 to infinity. It could be 0 to infinity. ऐसा हो सकता है वो टीम कोई गोल ही ना करे, हो सकता है 1 गोल करे, हो सकता है 2 करे, हमें नहीं पता कितने गोल कर सकती है एक सीजन के अंदर. वो 1000 गोल कर सकती है, 5000 गोल कर सकती है. Really there is no upper limit to that. Okay. Now if you go to PDC, these days it's pretty crowded. The number of people waiting in the line is also a random variable. Will take values 0, 1, 2, 3 and so on and so forth. Okay. It also can take values 0 to infinity, because we don't know the upper limit there. Well, we can put a bound that there can be only 6,000 maximum people on campus. That's the number of people that belong on campus, and only they can go to PDC. So in that case, the number of people waiting in the PDC line can be anywhere from 0 to 6,000. Now, I'm going to give you one more example before we move forward. Now, if you go to this PDC line, and you stand in the line, you will have to wait a certain amount of time. In the PDC line. The amount of time that you have to wait in order to get served in the PDC line, कितनी देर आपने इंतजार किया है, that is also a random variable. What values that random variable can take? Answers in the chat window. PDC की लाइन में वेटिंग टाइम कितना है? What values that random variable can take? That random variable can take any real value any real value between 0 and infinity. Can take any real value between 0 and infinity. It can take value 0, it can take value 0.5, it can take value 3.19, it can take value 7.294568. कुछ भी वैल्यू ले सकता है with infinite precision. Decimal points के बाद infinite precision value ले सकता है. So कितने की possible values हैं different? Well, this is an example of what we call a continuous random variable. Continuous random variable. Lifetime of a bulb is also a continuous random variable. Is also a continuous random variable. When you load a web page in your web browser, you type www.espncricinfo.com and the page loads. The time that it takes to load the page is also a continuous random variable. Also a continuous random variable. Okay. What values that continuous random variable will take? Will take value from 0.00000, very small amount of time, to minutes. Especially if you are on LUMS network, which is pretty slow these days, then it might take minutes. You can also have mixed random variables, which are discrete as well as continuous. We will give some examples. I'm going to write some facts and concepts here. One is function of a random variable is a random variable. Function of a random variable is a random variable. What is a function, by the way? Function क्या चीज होती है? Function क्या करता है? Function is a box. Function is a box जिसको आप एक नंबर इनपुट करते हैं और वो एक नंबर आउटपुट कर देता है. Number in and number out. This is exactly what a function does. X square plus 3x plus 2. X की वैल्यू इनपुट करेंगे, वो आपको एक नंबर आउटपुट कर देगा. So function just takes a number input and gives you a number output. But if we are talking about the function of a random variable, we know that a random variable is really a number. It can take one of the possible values with certain probabilities, but again, it is a number. In any case, it would be a number. Waiting time in PDC line or number of people waiting in PDC before you can get served. These are all numbers. Number of goals scored in a season by a team. These are all numbers. So random variable एक number ही होता है. So एक आपके पास sample space है और इस sample space में आपकी ये outcomes हैं जिसके ऊपर आपने उसको map किया है real line के ऊपर. Mapping की है. Mapping on real line. ठीक है? Real line पे mapping किया हुआ, it means that you have generated a random variable which can take one of the many possible values, and these possible values, when they get into this function, तो आपको एक और value मिल जाएगी. But really, I can combine this mapping function with the function here. तो इसका मतलब है ये जो number out जो हुआ है, you can think of these numbers out as these outcomes. ये जो outcomes हैं आपकी, mapping directly onto these numbers out. ठीक है? Mapping directly onto these numbers out. So that means these are also random variables. So in essence, the function of a random variable will also be a random variable. Okay. We can compute mean or expected value of a random variable. कैसे करते हैं? We will talk about that. Can also compute variance or standard deviation of a random variable. So, scores in quiz 2. हर स्टूडेंट के scores आए हैं हमारे पास. That is a random variable. X. If I pick a random student, if I perform the experiment, which is picking a random student from the class, and X is the number of the scores that this student got on the quiz 2. Okay, so example, pick a random student from the class. Marks of this student on quiz 2 is a random variable. Is a random variable. Okay. What values this random variable can take? Answers in the chat window. This random variable can take values 0, 1, 2, assuming that we don't give fraction numbers, up to 30. 0 to 30. What is the probability that x will take the value 30? Close to a high number. Well, for quiz 2, that number was very small. The highest scores in quiz 2 are not very exciting. Quiz 1 was something that on which students did much better than quiz 2. Okay, some more concept. A random variable can be conditioned. A random variable can be conditioned on an event, and also on a random variable, on another random variable. We talked about the concept of independence. Two events are independent when occurring of one event does not impact the probability of the other event. Same goes for the random variables. You can also talk about the independence of random variables. Whatever value one random variable can take, if you have two random variables, x and y, whatever value x can take does not impact what value y will take. जो y के PMF को change ना करे, x जो भी value ले ले, y का PMF अगर change ना हो, so then x and y will be independent. If x takes a value and that impacts the probability mass function of y, if I tell you that x has taken a specific value and that impacts the probability mass function of y, then y will be dependent upon x. Okay. So I will give a few more examples. But before we do that, let me just define. We talked about the probability mass function. I'm going to talk about what we call a distribution function or cumulative distribution function. कभी-कभी इसको खाली distribution function भी कह देते हैं. The full name is cumulative distribution function, CDF. Cumulative distribution function. So recall करें. Yes.
इंडिपेंडेंस ऑफ रैंडम वेरिएबल्स आपने बताया, उसको थोड़ा रिपीट कर दें. आप कह रहे हैं कि अगर हमारे पास जो आउटकम जिस इवेंट से आ रही हैं दोनों रैंडम वेरिएबल्स की, वो अगर इंडिपेंडेंट हैं आपस में.
नहीं, मैंने ये नहीं कहा. मैं ये कह रहा हूं कि x has a PMF Px of x, y has a PMF Py of y. Okay. If I tell you that x takes a value 7, that does not change the PMF of y, then x and y are independent. If I tell you that x takes value 39 and that changes the PMF of y, then y is dependent upon x.
Okay.
Okay. So slightly different. We will talk in lot more detail about the independence of the random variables. ये एक दो lectures जरा wait कर लें. So distribution function. What is distribution function? Remember, कि PMF was defined as probability that your random variable capital X taking a value small x, and the small x is a fixed number. कोई number होगा ये जिसको मैं 3 भी fix कर सकता हूँ, 4 भी, 5 भी. It's not a random variable. It is a variable, but it is not a random variable. Capital X is the random variable. So the probability mass function of x is the probability that x takes a value small x. Capital X takes the value small x. What is cumulative distribution function? ये नाम से ही पता चल रहा है कि कोई चीज accumulate हो रही है, कोई चीज जमा हो रही है. Okay? So cumulative distribution function, this is denoted by capital F small x and evaluated at x is equal to the probability that capital X takes a value less than and equal to small x. I can also write fx of 3 is equal to probability x takes a value less than equal to 3, or 7 less than equal to 7, or fx9 is equal to probability x less than equal to 9. Okay. So what is happening here is कि यहाँ पे वो सारी वैल्यूज x की जो 3 से छोटी या उसके बराबर हैं वो सारी वैल्यूज ने probabilities that x can take those values उन सबको add up करें. This will give you the cumulative distribution function. Both PMF uniquely identifies a random variable. अगर आपको मैं एक random variable का PMF बता दूं इसका मतलब है I have told you everything about the random variable. Similarly, CDF also uniquely identifies a random variable. If I tell you the CDF of a random variable, it tells me everything about the random variable. Everything. There is nothing more information, no more information about the random variable other than CDF or PMF. इन दोनों में से कोई एक बता दें, आपको सब कुछ पता चल गया. आपको सब कुछ पता चल गया. And vice versa is also true. If you know the random variable, what values it can take, and the corresponding if you know everything about the random variable, then you know the PMF. You also know the CDF. What that means is that if you know the PMF, you can find the CDF. Or if you know the CDF, you can find the PMF. You can find the PMF. Okay. So I will give you an example. CDF to PMF, and vice versa. How do you find that? So let's consider an example, and the example is, let's say x is a random variable, and the probability mass function is px1 is equal to 1 over 4, px2 is equal to 1 over 2, and px3 is equal to 1 over 8, px4 is also equal to 1 over 8. First question, is this a PMF? Is this a PMF? Answers in the chat window. Is this a PMF? Yes or no? Yes or no? Is this a PMF? Yes or no? Yes. Why? Answers in the chat window. Why is this a PMF? Well, one thing is for sure, that this sums up to 1. The other thing is कि ऐसा नहीं है मैं आपको 4 नंबर दे दूं और वो 1 पे ऐड होते हो तो वो PMF नहीं हो जाएगा. There is something more to it. It tells you that the values that the random variable can take, it tells you everything about those values. आपको ये बता रहा है कि ये 1 वैल्यू ले सकता है, 2 ले सकता है, 3 ले सकता है और 4 ले सकता है. इसके अलावा रैंडम वेरिएबल कोई और वैल्यू नहीं लेगा. और corresponding probabilities वो बता देगा. It tells you all the possible values that the random variable can take and the corresponding probabilities. That is why it is a PMF, and the probabilities obviously sum up to 1. That is why this is a PMF. ऐसे नहीं है कि मैं कुछ आपको वैसे 4 नंबर दे दूं वो 1 पे ऐड हो गए तो वो PMF नहीं बन जाएगा. PMF उस वक्त बनेगा when you have a random variable here, and we have a random variable present here. It tells you all the possible values that the random variable can take, and it does tell you that ये आपको चारों values बता रहा है जो ये ले सकता है, और corresponding probabilities भी बता रहा है, and those corresponding probabilities they sum up to 1, and this is a PMF. This is a PMF. I can plot this. Pxx is equal to, takes the value 1, takes the value 2, takes the value 3, and takes the value 4. And this is small x here, and this is the probability mass function of the random variable. I draw that probability mass function, takes the value 1 over 2, with probability 1 over 2, it takes a value 1. Oh, sorry, 1 over 4. One over 4, it takes the value 1. It takes the value 2 with probability 1 over 2. It takes the value 2 with probability 1 over 2. It takes the value 3 with probability 1 over 8. And takes the value 4 also with probability 8. Also with probability 1/8. So everyone is okay with that? This is a PMF. It tells you all the values that the random variable can take and the corresponding probabilities. This is your PMF. This is your PMF. Now, PMF is given. PMF is given. I need to find the CDF. Find the CDF. Find the CDF. CDF कैसे find करेंगे? We know the definition of CDF. Probability x less than equal to x is CDF. और इसको denote करते हैं fx of small x से. I need to find this value for all possible values of x. For all possible values of x. वो कैसे find out करेंगे? So सबसे पहले find out करते हैं probability x is taking a value less than 1. What is this probability? Answers in the chat window. जल्दी से बताएं. Answers in the chat window. Probability x takes the value less than 1. Oh, I know that it doesn't take a value less than 1. It takes the value 1 or 2 or 3 or 4. बस ये 4 values ले सकते हैं. ठीक है. What is the probability x takes a value less than equal to 1? Less than equal to 1. Less than equal to 1 is 1/4. What is the probability x takes a value less than 2? Less than 2. Answers in the chat window. Less than 2. Less than 2. Not less than equal to 2. It's less than 2. Less than 2 is also 1/4. Is also 1/4, not 3/4. Okay. The probability x takes a value less than equal to 2. Less than equal to 2. Probability x takes a value less than equal to 2 is equal to 1/2 plus 1/4. 1/4 plus 1/2, which is equal to 3/4. Okay. And then you can plot this. You can plot this. Okay. Probability x is less than equal to 3 is equal to, उसमें एक और 1/8 ऐड कर दें, plus 1/8 is 7/8. Probability x is less than equal to 4 is equal to एक और 1/8 उसमें ऐड कर दें, which is equal to 1. And then probability x is less than equal to 5, ये भी 1 ही रहेगा. Probability x is less than equal to 99, ये भी 1 ही रहेगा. So I'm going to draw the PMF, CDF now. I'm going to draw the CDF. Small x here, and then I will use this guy here. 1, 2, 3, and 4. Yeah. एक जैसी मैंने एक्सेस इनकी बना दी. So this is 1, 2, 3, 4. Okay. What is the probability that x takes a value less than equal to 1? See, CDF जो है वो क्या चीज है? CDF is probability x less than equal to x. So fx of x is equal to the probability x takes a value less than equal to x. Okay. So ये जो हमने सारी values लिखी हैं, इनमें से कुछ CDF की हैं. x less than 1 ये CDF नहीं है. ये CDF नहीं बता रहा. x less than equal to 1 ये मुझे CDF बता रहा है. ये CDF कहां बता रहा है? ये CDF बता रहा है कैपिटल fx of x, ये 1 के ऊपर, स्मॉल x जहां पे 1 है. This is a CDF value. This is a CDF value. This is not a CDF value. X is less than 2 is not the CDF value. क्योंकि डेफिनेशन के अंदर less than equal to है. डेफिनेशन के अंदर less than equal to है. खाली less than वाली जो चीज है वो CDF में नहीं आती. Less than equal to ये भी CDF में आता है. ये भी CDF में आता है, ये भी CDF में आता है. So I can plot this. X less than equal to 1. That means ये 1 जो है इसके ऊपर CDF की वैल्यू जो है वो आपके पास 1/4 है. So this is 1/4. और उससे पहले आपके पास वैल्यू 0. 1 से पीछे ये 0 है और यहाँ पे 1/4 है. यहाँ पे 1/4 है. और less than equal to 2 पे the CDF की वैल्यू at 2, CDF की वैल्यू at 2 is 3/4. Is 3/4. Is 3/4. And then constant Q. Less than equal to 3 is 7/8. Is 7/8. Is 7/8. लेस देन इक्वल टू 4 इज 1 और 5 पे भी 1 रहेगी, 6 पे भी 1 रहेगी और ये 99 तक बनी रहेगी। सो ये आगे तक चलती रहेगी। This will go on. This will go on. So this is your CDF. This is your CDF. ये capital FX of X, which is CDF. तो यहां से हमने कुछ चीजें नोट की। चीजें ये नोट की हैं कि जो CDF है is non decreasing, ये कभी डिक्रीज नहीं होगा। It is okay if stays constant. It is okay if it stays constant. ये हमें नजर आ रहा है ये काफी देर यहाँ पे कांस्टेंट ही रहा है इस रीजन के अंदर, यहाँ पे भी कांस्टेंट रहा है, यहाँ पे भी कांस्टेंट रहा है, इधर भी कांस्टेंट है, बट इट नेवर डिक्रीजेस एंड अगेन दैट कम्स फ्रॉम द डेफिनेशन, प्रोबेबिलिटी x लेस देन इक्वल टू 5, ठीक है, वो उससे बड़ी ही होगी प्रोबेबिलिटी x लेस देन इक्वल टू 3 हो, एटलीस्ट उतनी बड़ी जरूर होगी। सो इट्स ए नॉन डिक्रीजिंग फंक्शन। सो CDF properties
क्वेश्चन है ये आपने जो ड्रॉ किया
is non decreasing जी, क्वेश्चन पूछ लें।
सर ये आपके प्लॉट में ऐसा नहीं दिख रहा कि हमने जो लाइन लगाई है ये हॉरिजॉन्टल 3/4 1 और 2 के दरमियान, तो ये ऐसा लग रहा है कि जैसे इसकी प्रोबेबिलिटी 1 और 2 के दरमियान की जो है वो 3/4 है। क्यूमुलेटिव में तो लेस देन 2 जब हम कहते हैं वो 2 से सारी वैल्यूज लेस हैं, और अगर 4 कहें तो 4 से सारी वैल्यूज लेस की प्रोबेबिलिटी 1 है, तो वो डिपिक्ट नहीं हो रहा प्लॉट के अंदर इस तरह।
क्या चीज नहीं डिपिक्ट हो रहा?
फॉर एग्जांपल अगर हम लास्ट केस को देखें कि वैल्यू 4 एक्स रैंडम वेरिएबल वैल्यू 4, इसकी क्यूमुलेटिव डिस्ट्रीब्यूटिव फंक्शन जो है वो उसकी प्रोबेबिलिटी 1 है, लेकिन वो 1 की वैल्यू जो है वो शो हो रही है सिर्फ 3 और 4 के दरमियान में, नहीं
शो हो रही। ये 1 की वैल्यू जो शो हो रही है, ये मैं यहाँ पे दिखा देता हूँ, ये 1 है आपके पास, ये 4 से आगे है, 3 और 4 के दरमियान में 7/8 है।
चलें 4 से आगे वाली ले लें, लेकिन हमारे पास तो कॉन्सेप्ट तो यही है ना कि 4 और 4 से लेस देन जितनी भी वैल्यूज उनकी प्रोबेबिलिटी 1 है। तो
मुझे पता नहीं आप ये क्या बात कह रहे हैं
सर। P of x लेस देन इक्वल टू 4 वो वैल्यू 1 है ना
जी, ये वाली आप इसकी बात कर रहे हैं।
हाँ जी, तो वो प्लॉट के ऊपर नहीं चीज दिख रही।
प्लॉट के ऊपर साफ साफ नजर आ रहा है कि 4 के ऊपर जो वैल्यू है, CDF को आपने 4 पे इवैल्यूएट किया है, दिस इज fx ऑफ 4, और ये वैल्यू जो है ये 1 है। ये तो साफ साफ नजर नहीं आ रहा प्लॉट के ऊपर।
ये दिख रहा है कि जैसे 4 से ऑनवर्ड्स 1 है
जी, यही नजर आ रहा है। 4 से ऑनवर्ड्स भी 1 है, 4 के ऊपर भी तो 1 ही है ना। तो ये देखिए 5 के ऊपर भी 1 है, 6 के ऊपर भी 1 है, 99 के ऊपर भी 1 है, और ये 1 ही रहेगी फिर आगे।
ठीक है,
सही है। So if I ask you what is the probability that this is between 2 and 3, वो 7/8 है, वो 7/8 ही रहेगी 2 और 3 के बीच में। लेकिन वो CDF नहीं है, वो कोई और प्रोबेबिलिटी का क्वेश्चन है। CDF तो सिर्फ आपको एक प्रोबेबिलिटी के क्वेश्चन का आंसर करता है, व्हाट इज द प्रोबेबिलिटी x इज लेस देन इक्वल टू समथिंग, और दैट समथिंग गोज ऑन द x एक्सिस और उसकी वैल्यू जो है गोज ऑन द y एक्सिस। ठीक है। नाउ हाउ डू यू गेट द PMF फ्रॉम CDF? व्हाट वी नोटिस इज कि ये जो PMF की वैल्यूज हैं, ये 1/4 है, तो ये आप देखेंगे जंप आपके पास 1/4 का, ये 1/2 है, तो ये आपके पास जंप जो है ये 1/2 का आ गया, फिर ये 1/8 है, तो ये जंप 1/8 का है, फिर एक और 1/8 है, तो एक जंप आपके पास 1/8 का है। ठीक है। सो दैट मीन्स कि जंप्स इन द CDF will tell you about the PMF value, and the PMF values, they will tell you about the jumps in the CDF, and this makes sense. Why? Because PMF क्या कहता है? PMF कहता है probability x takes a value 4 और x takes a value 5 और x takes a value 3, जबकि CDF जो है वो क्यूमुलेटिव है, तो इसका मतलब है उसमें सारी पिछली वैल्यूज आ जाती हैं, देखिए x लेस देन इक्वल टू x है। अगर ये PMF होता तो वो प्रोबेबिलिटी x इज इक्वल टू x होती। तो चूंकि पिछली वाली सारी वैल्यूज आ जाती हैं, तो यहाँ पे हमें जंप करवानी होगी, उसको उससे ऊपर ही ऊपर जाना होगा। ठीक है। So CDF is a non-decreasing function, Also, limit b going to infinity, f(x) of b is equal to 1. Always will be equal to 1. What is the probability x takes a value less than equal to infinity? Always. What is the probability x takes a value less than is equal to infinity? Always will take a value less than equal to infinity. It's a random variable. Will take some value, and all of those values will be less than equal to infinity. So you can see कि ये जो CDF हमें ये आखिरी वाला पोर्शन नजर आ रहा है, 4 से आगे वाला. So ये इसको इन्फिनिटी तक भी खींच के ले जाएं, ये 1 ही रहेगा. और ये जैसे हमने आपको बताया कि the PMF jumps, the PMF values indicate what are the jumps in the CDF. तो आखिर तक पहुंचते मैंने पूरा PMF ऐड कर दिया है. आखिर तक पहुंचते पूरा PMF ऐड कर दिया. देखें पहले 1/4 है, उसमें 1/4 में 1/2 का जंप आया, फिर उसमें एक और 1/8 का जंप आया, फिर एक और 1/8 का जंप आया. तो ये चारों वैल्यूज ऐड हो गई. एंड वी नो दैट दिस इज अ PMF, so all these values should add up to 1. Since these all values add up to 1, तो इसका मतलब है कि ये बस 1 अब कांस्टेंट रहेगा. 1 से ऊपर नहीं जा सकता. You cannot have the probability of something greater than 1. 100% से ज्यादा तो चांस नहीं हो सकता किसी चीज का. ठीक है. And similarly, limit b going to 0, f(x) of b would be equal to f(x) of b would be equal to 0. b going to not 0, minus infinity. Sorry, minus infinity. 0 पे तो कोई वैल्यू हो सकती है. Minus infinity. What is the probability x takes a value less than equal to minus infinity? Well, there is no chance. It will take some value between plus infinity and minus infinity. लेकिन minus infinity की value ये नहीं ले सकता और उससे नीचे भी नहीं ले सकता, because वो हमारी real line के बिल्कुल end point पे चली गई. Okay. Now, this guy, probability x is less than b. इसमें और probability x less than equal to b. This is my CDF. F of x, evaluated at b. This is my CDF. इस CDF में और इस probability question में इनके दरमियान क्या relationship है? Are they equal? Not equal? Well, they may or may not be equal. ये जो ऊपर हमने example दिया, they will not be equal, but they can be equal for certain values. What is the probability? If I ask you the question, what is the probability x is less than, let's say, 3? And what is the probability x is less than equal to 3? What is the probability x is less than equal to 3? In this case is 7/8. What is the probability x is less than 3? ये इस फिगर को देख के आंसर बताएं. What is the probability x is less than 3? Answers in the chat window. What is the probability x is less than 3? The probability that x is less than 3 is 3/4. It's 3/4. So not equal. What is the probability x is less than 2.5? And what is the probability x is less than equal to 2.5? What is the probability x is less than 2.5 or less than equal to 2.5? This would be equal to 3/4 and 3/4. ये इस केस में equal. Why is this the case? कि ये कभी तो unequal आ जाते हैं और कभी equal आ जाते हैं, because we have these jumps. In the CDF. ये CDF के अंदर हमें jumps नजर आ रहे हैं. अगर ये jumps ना हो, so it would always be true that probability x is less than b would be equal to probability x less than equal to b. Only when you don't have any jumps. ये discrete jumps जब आपके पास आ जाएंगे, तो this will make this difference कि एक ही point के ऊपर less than अगर होगा तो वो आप jump के पीछे बैठे हैं, और वो point अगर include हो गया तो आप jump होने के फौरन बाद बैठे हैं. So that means these probabilities would be unequal. Discrete random variables में ये अक्सर ऐसा होगा कि these two guys will not be equal. Continuous random variable के केस में they will always be equal. Mixed के केस में कहीं इक्वल होंगे कहीं नहीं होंगे. So there is an example in the notes. We will upload the notes. Please take a look at the notes. Okay. Now you can answer all probability questions about the random variable. Can answer all probability questions about the random variable using either PMF or using CDF. Why is that the case? Because PMF tells you everything about the random variable. Similarly, CDF also tells you everything about the random variable. Since these guys tell you everything about the random variable, which means you can answer any probability question about the random variable by using the information from PMF or by using the information from the CDF. सब आंसर कर सकते हैं कैसे? एग्जांपल देते हैं. एग्जांपल ये है, what is the probability x is greater than a? X is greater than a. I can answer this. 1 minus probability x is less than equal to a. This is equal to 1 minus capital Fx of a. 1 minus the CDF evaluated at a. 1 minus the CDF evaluated at a. What is the probability? A is less than x less than equal to b. This, you can verify this, would be equal to fx of b minus fx of a.
सर ये कर्सर हटा दें प्लीज, आपका माउस का
क्या चीज जी?
कर्सर आपका नोट्स के ऊपर आ रहा है, माउस का कर्सर
नोट्स के ऊपर आ रहा है. Is everyone seeing that problem? So मुझे पता नहीं है कर्सर.
सर ये आपका कर्सर आया हुआ था स्क्रीन,
अब चले गया.
अभी चला गया?
हाँ जी.
ठीक है. Okay, so you can answer all the probability questions about the random variable by using either the CDF or by using the PMF. Now, I'm going to ask this question: what is the probability x is less than b? This is not something that the CDF directly answers. CDF इसका जवाब नहीं देगा. हाँ, हम इसको ये जरूर कर सकते हैं कि हम इसके ऊपर लिमिट्स लगा दें. Probability x is less than b is equal to probability limit n going to infinity x is less than equal to b minus 1 over n. So n tending to infinity, so 1 over n will tend to 0, so b minus 1 over n will tend to b. So this will be equal to limit n tending to infinity, probability of x is less than equal to b minus 1 over n, which is equal to limit n going to infinity, capital Fx. This is your probability x less than equal to something. X less than equal to something is the CDF. So this is equal to CDF b minus 1 over n. So now if you notice कि ये अगर आपका CDF चल रहा है, so ये CDF है, इस तरह का CDF अगर आपका चल रहा है. So let's say you have this point B here. यहाँ आपके पास B है, ठीक है. So probability x less than b, कौन सी वैल्यू होगी? वो ये वाली वैल्यू. And the probability that x is less than equal to b would be this value. तो ये एक डिफरेंस होगा इसमें, So there is some details in the notes. Please take a look at that. So I'm going to talk about mean value of a random variable, mean or expected value value of a random variable. So I will give you an example. Okay, you have 125 students in the class or 121 students in the class. Okay, everyone takes a grade on quiz 2. हर एक का कोई marks आ गए हैं quiz 2 के. ठीक, I pick a random student और मुझे उसके marks देखते हैं. तो वो marks जो हैं वो कितने होंगे? It would be a random variable between 0 and 30. It would be a random variable between 0 and 30. किसी और student को अगर pick करें तो would be another value of that random variable. So जितनी बार मैं ये experiment perform करूंगा, random variable will take values. बिल्कुल उसी तरह जैसे when you perform the experiment, एक दफा perform किया तो एक outcome आएगी, दोबारा perform करेंगे तो एक और outcome आएगी. Same भी हो सकती है, कोई different भी हो सकती है. In exactly the same way, when you perform the experiment once, you pick one student from the class, you will get a random variable. If the random variable is defined as the marks on quiz 2. So random variable will take a value when you perform the experiment once. Random variable will take a value when you perform the experiment once. You pick a random student from the class. You pick another random student from the class. It could be the same student or could be another student. Then the random variable will take another value. Okay? Or maybe the same value, but different views. So all of these values that the random variable can take, it can take those values with certain probabilities. What is the mean of those values? Because I know that each of the 121 students is equally likely, 1 by 121 probability for each of the students to be picked up. Each of the students has an equally likely probability to be picked up. I need to find out, okay, what is the probability that I pick a random student, ठीक है, उसका जो score आएगा, expected value उस random variable की क्या है? What is the expectation? जरूरी नहीं है वो expected value आपको मिल भी जाए, because हो सकता है आपको expected value मिले 17.39, जो mean value हम calculate करते हैं क्लास के scores की, average value जो calculate करते हैं, that is a value that no student gets probably. 17.34 किसका score आया होगा? किसी का भी score नहीं आया होगा. But still it's a value that you expect out of that random variable. It's a value that you expect out of that random variable. Okay. So expected value or mean value, if X is a random variable with PMF P capital X small x, इसको ऐसे भी लिखते हैं कि X is a random variable with PMF PXX. Another way of writing it, ये equivalent चीजें हैं, दोनों चीजें. Then expected value of X, mean of X or expected value of X, इसको ऐसे denote करते हैं, is equal to all the possible values that X can take, multiplied with the corresponding probabilities. So देखें, PMF आपको list of values दे देता है जो random variable ले सकता है, and the corresponding probabilities. You multiply each of those together and sum those up. That gives you the expected value of the random variable. I'll give you an example. Example के बगैर हम नहीं जाएंगे. So the example is, let's say you have a random variable Z, probability mass function of Z is 1/4, and PZ of takes a value 7 is equal to 3/4. How many values Z can take? How many different values Z can take? How many different values Z can take? Z can take two values. Bilal, the discussion that you guys are having, discrete का मतलब ये नहीं है कि 0, 1, 2, 3, 4 ये values हैं. Discrete का मतलब है कि these are the values that are discrete, which means you can count them. Okay? And you can also count 0, 0.1, 0.2, 0.3, 0.4. Nothing in between. So 0, 0.1, 0.2, 0.3, 0.4, 0.5, 1.5, 1.6, 1.7. These are all discrete values. You can count those. If you can count those, then these are discrete values. Counting करने का ये मतलब नहीं है कि वो आपके पास whole numbers ही हैं. Counting करने का ये हरगिज मतलब नहीं है कि आपके पास ये whole numbers हैं. Okay. So coming back to this example, if you have a random variable z and the random variable z takes these two values 5 and 7, takes these two values, then expected value of z is 5 into 1 by 4 plus 7 into 3 by 4, 7 into 3 by 4, whatever that value comes out to be. So indicator random variable of an event. Let me just define that. Let's say there is an event. Let's say there is an event A. Define the indicator random variable of event A called IA, which takes value 1 if A occurs and 0 if A does not occur. I am interested in finding out what is the expected value of IA. IA is a random variable. It's a random variable. What values it can take? It can take values 1 and 0. It can take value 1 with probability that A occurs. So it takes value 1 with probability that A occurs, and takes a value 0, probability that A does not occur. Okay. So this is equal to P of A. So the expected value of the indicator random variable of an event is equal to the probability of that event. Now, I'm going to talk about the function of a random variable. Function of a random variable. What is meant by a function of a random variable? Y is equal to small g of x. So ये एक बॉक्स है आपका g dot. इसके अंदर values in and values out. X की values in, X values in, and Y values out. So this is a function. Function है यही काम करता है ना. एक चीज इनपुट जाती है और एक आउटपुट निकाल देता है. Okay. So if X is a random variable, then Y is also a random variable. If X is a random variable, then Y is also a random variable. We already talked about that. Okay. If Y is a random variable, okay, it will have a PMF as well as a CDF. Y का एक PMF भी होगा, एक CDF भी होगा. Knowing the PMF or CDF of X, I can find the PMF or CDF of Y. I can find the PDF or PMF or CDF of Y if X का जो है CDF दिया हो या X का PMF दिया हो. Well, X के बारे में information है तो आपको Y के बारे में information मिल जाएगी, and that makes sense because this box is a fixed box. अगर आपको वैसे ही मैं आपको बता दूं कि ये आपको फंक्शन दिया हुआ है जो स्क्वायर करता है और स्क्वायर करके उसके अंदर एक कांस्टेंट वैल्यू ऐड कर देता है, तो जो भी इनपुट आएगी यू कैन ऑलवेज टेल व्हाट द आउटपुट विल बी. ठीक है, एंड द कॉरेस्पॉन्डिंग प्रोबेबिलिटीज विल आल्सो बी मैचिंग. सो x के बारे में अगर सब कुछ पता हो तो मुझे y के बारे में भी सब कुछ पता चल जाएगा. सो x का CDF पता हो तो y का CDF पता चल जाएगा. x का PMF पता हो तो y का PMF पता चल जाएगा. X का CDF पता हो तो y का CDF पता चल जाएगा, y का PMF पता चल जाएगा, y के बारे में सब कुछ पता चल जाएगा.
सर अगर y का PMF भी पता हो और x का भी पता हो और हम g फाइंड कर सकते हैं फिर?
नहीं, नॉट नेसेसरली. यूनिक नहीं होगा. G uniquely determined नहीं हो सकेगा. So let's say X is the sum of faces of two dice. दो डाइस ली, उनको रोल कर दिया, जो भी सम आया that is defined as the random variable. What values X can take? Answers in the chat window quickly. Two to 12. X takes the value 2, 3, 4 all the way up to 12. What is the probability that X takes a value 2? What is the probability X takes a value 2? Answers in the chat window. 1 by 36. दोनों पे 1 1 आएगा तभी तो सम 2 होगा. What is the probability x takes a value 3? Answers in the chat window quickly. 3 लाने के लिए या 1 और 2 आ जाए या 2 और 3 आ जाए, वही आप वो 36 पॉइंट्स वाली डायग्राम बना के you can easily answer this 2 by 36. Similarly, etc. etc. So I can find this PMF. ये भी पूरा PMF नहीं है, हम ये पूरा find कर सकते हैं. Define a function of this random variable y is equal to x plus 3. What values y will take? What values y will take? Answers in the chat window. What values y will take? Y takes the values. हर x की हर वैल्यू जो है उसमें 3 ऐड हुआ है, ठीक है. जब x2 आएगा तो y जो है वो 5 हो जाएगा, जब x3 होगा तो ये 6 होगा, डॉट डॉट डॉट, x12 होगा तो y 15 होगा. And I know all the probabilities. X की ये क्या probabilities हैं taking values 2 to 12. I can directly write the PMF of y taking a probability value of 5 with probability 1 by 36. So Py of 5 is equal to 1 by 36. Py of 6 is equal to 2 by 36, etc. इस तरह ये x की वैल्यूज कंप्लीट करेंगे, इसी तरह y की वैल्यूज भी सारी कंप्लीट कर सकते हैं, ठीक है. कभी कभी ऐसा होगा, इस केस में तो ऐसा नहीं हुआ, कभी कभी ऐसा होगा कि x की दो वैल्यू जो है वो y की एक ही वैल्यू को मैप हो जाएंगे. Sometimes multiple x values will map to a single y value. I'll give you an example. उसकी example भी देते हैं. Example. What to do in that case? So let's say you have pxx is 6 minus 1, 0 and plus 1 with probability 1 by 3, with probability 1 by 3, with probability 1 by 3, with probability 1 by 3. ये तीन values लेता है. How does the PMF look like? The PMF looks like the following. ये 1 by 3 value लेता है, probability लेता है with these three values. This is the PMF of x. This is the PMF of x. Okay. Takes value minus 1 with probability 1 over 3, takes value 0 with probability 1 over 3, takes value plus 1 also with probability 1 over 3. Okay. Also with probability 1 over 3. Define y is equal to modulus of x, magnitude of x. Okay. What values y can take? Answers in the chat window. What values y can take? Answers in the chat window. 1 and 90. Y can take a value 0 and 1. Y can take a value 0 and 1. Y will take a value 1 with probability. Y will take a value 0 with probability. So I need these answers. So Y takes a value 1 with probability. Answers in the chat window. Takes a value 1. When does Y take a value 1? Y takes a value 1 whenever x is minus 1 or whenever x is plus 1. These are two mutually exclusive events. X taking a value minus 1 and x taking a value plus 1. These are mutually exclusive events. X या ये value ले value या ये value ले लो, which happens with probability 1 by 3 each. So this happens with probability 2 by 3. And Y will take a value 0 when x takes the value 0, which happens with probability 1 by 3. So what is really happening here is Y is taking Py of Y. Y is taking, by the way, ये small y जो है, ये डमी सा वेरिएबल है, इसकी जगह मैं कुछ भी W भी लिख सकता हूँ, X भी लिख सकता हूँ, बस कंफ्यूजन से बचने के लिए इसको ये अलग से y लिख देते हैं. So Y takes two values. It takes a value 0 and it takes the value 1. And it takes a value 0 with probability 1 over 3. It takes a value 1 with probability 2 by 3. And you will notice that this value of x, 0, gets mapped to this value of y. Okay. And these two values of y, x, ये -1, ये y1 में मैप हो गया और ये +1 जो है ये भी जाके इसमें मैप हो गया. Both of these values got mapped into 1. Okay. So I can find the expected value of y, which is 1 into 2 by 3 plus 0 into 1 by 3, which is equal to 2 by 3. Let me also define on the same problem, let me also define z is equal to x square plus 5. Possible values z can take. Z can take which values? What are the possible values z can take? मुझे उसका PMF चाहिए. Z can take values 5. When x takes the value 0, it will take the value 5. When x takes the value -1, it takes the value 6. When it takes the value, x takes the value +1, it still takes the value 6. So px0, this is 1/3, and pz5 is 1/3, and this is equal to 2/3. Similarly, I can draw the PMF of z as well. I can also draw the CDF of y. I can also draw the CDF of x. I can also draw the CDF of z. So you can find the expected value of z to be equal to 5 with 1/3 and 6 with probability 2/3. जो भी बहुत सारा. So अगर हमें एक रैंडम वेरिएबल दिया और दूसरा उसका फंक्शन हो, क्या हमें दूसरे का PMF फाइंड करना जरूरी है? Not necessarily. Now I can find the expected value of a function of a random variable. Expected value of a function of a random variable. And the expected value of a function of a random variable, expected value of gx, is the same. We do understand that g of x, which is a function of a random variable, is itself a random variable. So it makes complete sense to talk about the expected value of this random variable g of x. This is also a random variable. It is perfectly all right to talk about the expected value. G of x का एक PMF होगा, एक उसका CDF होगा, and this is equal to summation I all g of xi into px of xi. Very quick example. It'll take just 1 minute. So let's say you are given the probability mass function of x to be equal to 0.2, px of 0 is 0.5, and px of 1 is equal to 0.3. This is the PMF of x. So let me define y1 to be equal to x plus 3. y1 to be equal to x plus 3. I can find the PMF of y1. I can find the PMF of y1, and I can also find the PMF of. I can also find the expected value of y1. So what is the expected value of y1? पहले आप ये बताएं कि expected value of x क्या होगी? Expected value of x ये होगी -1 into 0.2 plus 0 into 0.5 plus 0.3 into 1 plus 1 into 1, which is equal to 0.1. So expected value of x is equal to 0.1. So y1 is equal to x plus 3. What are the possible values y1 can take? Y1 can take the values 3 minus 1, which is 2, 3 plus 0, which is 3, and 3 plus 4. So y1 can take these values. Okay. Py1, 2, Py1, 3, and Py1, 4. Takes these values with corresponding probabilities 0.4, 0.5, and 3. And expected value of y is equal to 2 into 0.2 plus 3 into 0.5 plus 4 into 0.3, which turns out to be equal to 3.1. 3.1. Note करें कि expected value of y1 is expected value of x plus 3. And this makes complete sense to us. Why? Because we have defined a random variable y1 as x plus 3. ये यूं समझ लें कि if everyone in the class gets 3 extra points on quiz 2, तो class की average जो है वो 3 units ऊपर चली जाएगी. Exactly 3 units ऊपर चली जाएगी. So y1 is a random variable, which is the new scores, which is 3 added to every student's score. So the average of y1 would be 3 greater than the average of x. जो quiz में रेगुलर स्कोर्स आए हैं, अगर उसमें 3 ऐड कर देंगे सो दैट मींस क्लास एवरेज जो है वो आपकी 3 से ऊपर चली जाएगी. नाउ बी पार्ट, what if multiple values of x map to same value of y, same value of y1. well same value, अब y1 नहीं, मैं एक और रैंडम वेरिएबल डिफाइन कर देता हूं, एंड लेट मी कॉल same value of another random variable y2. तो y2 मैं डिफाइन करता हूं, y2 is equal to x square. See, x हमारे पास क्या था, x -1 0 and 1 with 0.2 0.5 0.3. so y2 takes two values, takes values 0 and 1, py2 0 and py2 1. what is py2 0? py2 0 is when x takes the value 0, which happens with 0.5. py2 1, what is py2 1 is equal to px minus 1 plus px plus 1. जब भी x minus 1 होगा तो y2 जो है 1, जब x plus 1 होगा तब भी y2 1 है, which is also equal to this 0.2 plus 0.3, which obviously is 0.5. and you can see that this 0.5 and this 0.5 added together they sum up to 1. ये y2 का complete PMF है. then expected value of y2 is equal to 0 into 0.5 plus 1 into 0.5 is equal to 0.5. This is by using PMF of y2. I can find the expected value of y2. I can find the expected value of y2 using expected value of function of random variable formula. ये हमारे पास एक फॉर्मूला है जिसको हम यूज कर सकते हैं, and this formula is given here. Your expected value of g of x is summation g of x px, उसको यूज करके देखते हैं, and that is equal to summation, what is g of x? G of x into px of x, which is equal to summation. We have defined y2 to be equal to x square. So ये हमारे पास x square था और साथ में px of x, which by the way turns out to be the same. कि ये -1 का स्क्वायर है, x takes the value -1 with probability 0.2, 0 with 0.5 and 1 with 0.3. So -1.2 plus 0 square into 0.5 plus 1 square into 0.3, which is equal to 0.2 plus, which is equal to 0.5. And you can see that this is exactly the same answer. ये पहले जो हमने निकाला है वो यूजिंग पीएमएफ ऑफ y2 था, उसके लिए हमें पहले y2 का पीएमएफ निकालना पड़ा, उस पीएमएफ से हमने एक्सपेक्टेड वैल्यू निकाल ली. लेकिन I can do a shortcut without finding the PMF of y2. I can use this expected value of a function of random variable formula. इस फॉर्मूले को यूज करके डायरेक्टली x के PMF से और इस फंक्शन को यूज करके I can directly find the expected value of y2. I can directly find the expected value of y2. So, apologies, we are a little bit over time. 10 minutes up, 8 minutes up. So I will stop here and we will pick up on Friday from where we have left today. Next lecture जो है वो हम Friday को करेंगे. 8. And that will be on October 1st, 20. So before I close, any questions?
सर हमने प्रोबेबिलिटी में पढ़ा था कि इसको बजाय इसके कि हम समेशन के अंदर जाके स्क्वायर करें, तो इसके कुछ फार्मूलास भी होते हैं, यानी कि अगर एक्सपेक्टेड वैल्यू के ऊपर स्क्वायर है तो वो उसके कुछ फॉर्मूलाज होते हैं, तो वो हम पढ़ेंगे या ऐसे ही सबमिशन के अंदर जाके करेंगे?
प्रोबेबिलिटी का कोर्स है तो वो सब पढ़ेंगे, अभी पढ़ा नहीं है लेकिन आ जाएगा, नेक्स्ट लेक्चर में आ जाएगा। उस्मान, आपका जो क्वेश्चन है, उस्मान निजामी, आपने जो चैट विंडो, so I had said earlier के I don't read the chat window when I am writing here. It is very rare that I will read the chat window unless I am asking a question. So it is best के आप जो है वो माइक्रोफोन से पूछ लें। So ये जो आपने लिखा हुआ है probability x less than b is equal to f of b minus p of b. b is a number and p of b does not make any sense. Probability of a number does not make any sense.
Sir, what about in discrete case?
Even in the discrete case, I can only have the probability of an event. I cannot have the probability of number 5. What is the probability of 5? It does not make sense. ये senseless चीज है ये पूछना ना. So probability x is less than 3. This is an event, makes sense. Probability x is less than or equal to 4. It's an event, makes sense. Probability of 5 does not make any sense. 5 is not an event. It is just a number. I can say that probability x less than or equal to 4 is fx of 4. Fx of 4. So it is okay to talk about fx of 5. Okay to talk about that, which is equal to the probability x less than or equal to 5. But इसको मैं ये नहीं लिख सकता कि probability of 5. ये इसका कोई मतलब नहीं।
Okay, sir.
सर वो जहाँ पे हमने लिमिट्स डिफाइन की थी, लिमिट एक्स अप्रोचेस इन्फिनिटी पी ऑफ बी, वो काइंडली आप वहाँ पे जाएंगे?
जी जी, ये यहाँ पर डिफाइन,
थोड़ा ऊपर सर।
ये है राइट?
नहीं सर, इससे मैं ऊपर क्वेश्चन करना चाह रहा हूँ, यहाँ पे। जी
हाँ
जी
जी।
सर। अच्छा सर, यहाँ पे हमने लिखा है कि लिमिट बी अप्रोचेस नेगेटिव इन्फिनिटी, तो इसको हमने 0 लिखा है।
जी
तो सर इसमें मैं ये पूछना चाह रहा हूँ कि अगर बी हमारा ऐसे हो कि क्लोज टू पॉजिटिव इन्फिनिटी और हम रिवर्स जा रहे हो, तो उसमें भी ये 0 ही होगा, इसको हम 1 नहीं ले सकते?
क्लोज टू पॉजिटिव इंफिनिटी,
सर यानी हम पॉजिटिव इन्फिनिटी से नेगेटिव इन्फिनिटी जा रहे हैं, कुछ इस तरह का सीन हो, तो उसमें 1 नहीं हो सकती?
नहीं, रैंडम वेरिएबल क्या वैल्यू ले रहे हैं? सी fx of b, ये जो यहाँ लिखा हुआ है, this is the probability x takes a value less than or equal to b according to the definition of the CDF. तो अब आप बताएं, आप क्या कह रही हैं? x जो है एक इंफिनिटी की वैल्यू ले रहा है।
सर जैसे हमने इसके ऊपर लिखा है लिमिट बी अप्रोचेस इन्फिनिटी एफ एक्स ऑफ बी इज इक्वल टू 1,
जी,
तो इसी तरीके से हम नीचे ये 0 वाला मुझे समझ नहीं आया, ये कैसे है?
ये क्या चीज इसमें नहीं समझ आई है? मैं ये कह रहा हूं कि व्हाट इज द प्रोबेबिलिटी x टेक्स अ वैल्यू लेस देन इक्वल टू b. So this is basically when b goes to minus infinity, I'm asking what is the probability x takes a value less than equal to minus infinity. Minus
ठीक है
infinity
सर।
से छोटी वैल्यू कैसे ले सकता है?
ठीक है सर, क्लियर हो गया।
ठीक है, नहीं ले सकता ना।
जी। और
ये
सर ये
वैसे
जो
ग्राफ से भी देखें, ये ग्राफ से भी देख लें कि ये ग्राफ जो है ये नॉन डिक्रीजिंग ग्राफ है। सो ये माइनस इंफिनिटी पे ये 0 को टच करेगा और प्लस इंफिनिटी पे ये वाला जो ग्राफ है CDF का, दिस CDF ग्राफ, ये माइनस इंफिनिटी पे ये 0 पे पहुंच जाता है और प्लस इंफिनिटी पे ये 1 को पहुंच जाता है।
ठीक है सर। सर इसी ग्राफ से एक कंफ्यूजन एक और ज़हन में आ रही है कि ये जो हमने लिखा है प्रोबेबिलिटी x लेस देन इक्वल टू 4, ये 1 है, लेकिन सर ग्राफ में जो डिपिक्ट हो रहा है वो ग्रेटर देन इक्वल टू 4 पे ये 1 है।
ऐसी बात नहीं है, ऐसी बात नहीं है। ये जो हमने प्लॉट किया हुआ है ये CDF प्लॉट किया हुआ है। जो हमने प्लॉट किया है वो fx डॉट ये प्लॉट किया है। जो x एक्सिस पे जो चीज है वो उसके आर्गुमेंट है। सो f(x) of 4 का क्या मतलब है? f(x) of 4 का मतलब है probability x is less than equal to 4। ठीक है,
जी
सो अगर मैं आपसे पूछ रहा हूं व्हाट इज द प्रोबेबिलिटी x is less than equal to 4, ये मुझे बताएं, तो आप कहेंगे उप्स, सो आप कहेंगे ठीक है, प्रोबेबिलिटी x लेस देन इक्वल टू 4 क्या चीज होती है? प्रोबेबिलिटी x लेस देन इक्वल टू 4 होती है f(x) of 4। सो ये एक फंक्शन है जिस फंक्शन की वैल्यू ग्राफ से रीड कर लेते हैं। 4 पे उसकी क्या वैल्यू है? 4 पे उसकी वैल्यू है ये,
ठीक है
4
सर,
पे उसकी
थैंक यू।
वैल्यू जो है वो 1 है। ठीक है, सो डोंट फॉरगेट कि ये जो ग्राफ आपको शो कर रहे हैं इसके अंदर लेस देन इक्वल टू ऑटोमेटिकली बिल्ट इन है, इस फंक्शन के अंदर ऑटोमेटिकली बिल्ट इन।
सर चैट बॉक्स में एक क्वेश्चन भेजा है।
सॉरी, चैट बॉक्स में क्वेश्चन पूछ लें यार, वैसे ही पूछ लें। अच्छा, कैन वी राइट प्रोबेबिलिटी x लेस देन b इज इक्वल टू f of b minus probability x is equal to b? आंसर इज यस, आंसर इज यस। सो आप ये कह रहे हैं कि प्रोबेबिलिटी x इज लेस देन b, हम ये लिख सकते हैं, ऊपर ही लिख देते हैं, probability x is less than b, can I write it probability x is less than equal to b minus probability x is equal to b? So obviously ये तो आंसर है, ये तो बिल्कुल ठीक है। और ये वाली जो चीज है, this is the CDF evaluated at b, this guy here is capital F(x) of b। तो जो आपने लिखा है ये बिल्कुल सही है। Okay. Any other question before I close the session? All right. So thank you very much for showing up this morning. I will stop the share and close the session. We'll upload the lecture as soon as it is available.